In question number 21, in the given potentiometer circuit, length of wire AB is 1 meter and its resistance is R is equal to 9 ohm. The length AC for no deflection in galvanometer is. So when there is no deflection in the galvanometer, then the current through the galvanometer will be 0. So in that situation, the current will move in the circuit in this fashion and the current will move in the circuit in this fashion. So in that case, the current in this circuit is 1 ampere. The potential difference between A and B would be 9 volt. In the same way, the current in this branch is 1 ampere. So the potential difference between these 2 points would be 3 volt. So we can say the potential difference between A and C must be 3 volt. So potential difference is proportional to L in case of potentiometer. Since V is proportional to L, so length AB is 1 meter. So AB is proportional to potential difference, that is 9 volt, and AC is proportional to potential difference, that is 3 volt. So AC is equal to 1 by 3 of AB, and the length of AB is 1 meter, so the length of AC is 1 by 3 meter. So option 2 is the correct answer. Let's move to question number 22. In question number 22, for the circuit shown in figure at t equal to 0, charge on capacitor is CE by 3. Find charge on capacitor C as a function of time t. So at any time t, the charge on the capacitor can be written as Qt is equal to A plus B e raised to the power minus t by RC. So at t equal to 0, charge on the plate of capacitor is CE by 3. So at t equal to 0, it can be written as A plus B. And when t approaches infinity, then the charge on the plate of the capacitor is C. So that is equal to A. So on solving, the value of B comes out to be minus 2 by 3 of C. So if I substitute the value of A and B here and solve, then the Qt comes out to be CE plus, that is minus of 2 by 3 CE into e raised to the power minus t by RC. Now add 2 by 3 CE and subtract 2 by 3 CE. So on further solving, it can be rearranged in this way, that is CE by 3 plus 2 times CE by 3 into 1 minus e raised to the power minus t by RC. So we can say that option 1 is the correct answer. Let's move to question number 23. In question number 23, two infinite wires are kept parallel to z-axis as shown in figure. Each wire carries current I0 along positive z-axis. Considering only magnitude of magnetic field, number of points on x-axis where magnetic field is equal but not 0 will be. So if I draw the variation of magnetic field when only magnitude is considered, then the variation is something like this. This is the variation. So at any particular separation, we can consider there are 4 points at which the magnitude of magnetic field is same. So option 2 is correct. Let's move to question number 24. In question number 24, two bodies A and B are joined through a conducting rod of high thermal conductivity. A and B are thermally insulated from surrounding. Initial temperature of A and B is 100 degrees Celsius and 20 degrees Celsius respectively. After 1 hour, temperature of A is 75 degrees Celsius and B is 35 degrees Celsius. After another 1 hour, temperature of A will be. Let's analyze the situation. This is body A and this is body B, and they are connected by a high thermal conductivity rod. Now let at any time t, its temperature is T1 and its temperature is T2. Initially at t equal to 0, the temperature of A is 100 degrees Celsius and that of B is 20 degrees Celsius. After 1 hour, the temperature of A is 75 degrees Celsius and that of B is 35 degrees Celsius. Now, if I find out what is the final temperature of bodies A and B. So in order to find out this, we know that in 1 hour, the heat lost by A is equal to the heat gained by B. So M1 S1 into 100 minus 75 is equal to M2 S2 into 35 minus 20. And when the final temperature is T, in that case I can write M1 S1 into 100 minus T is equal to M2 S2 into T minus 20. So if I solve this equation, then the value of T comes out to be 50 degree Celsius. So the final temperature of body A and B is 50 degree Celsius. We know that the temperature difference between the two bodies at any time T is exponential in nature. So the temperature of body A as well as the temperature of body B is also exponential in nature, because minus M1 S1 into dt1 by dt is equal to Ka by L into T1 minus T2, and for body B we can write M2 S2 into dt2 by dt is equal to Ka by L into T1 minus T2. So from these two equations, if I solve, then it comes out to be dt by dt of T1 minus T2 is equal to some constant, let's see, into T1 minus T2. So from here we can suggest that the temperature difference at any time T between the two bodies is an exponential function of time. So the temperature of body A as well as the temperature of body B also varies with respect to time. So I am writing the temperature of A at any time T as A plus B into e raised to the power minus lambda into T. So at T equal to 0, the temperature of body is 100. So 100 is equal to A plus B. And after a long time, the final temperature of body A is 50. So 50 is equal to A. So on solving, the value of B also comes out to be 50. Now, if I find out what is the value of lambda, then at T equal to 1 hour, the temperature of A is 75 degrees Celsius. So if I substitute the value of T as 75 here, this is 50, this is 50, and value of small t as 1 hour, then the value of lambda comes out to be ln2 divided by 1 hour. So if I find out the temperature of body A after another 1 hour, that is from the initial, now it is 2 hours. So we can write in this way, this is equal to 50 plus 50 into e raised to the power minus lambda, that is ln2 by 1 hour into 2 hours. So it comes out to be 50 plus 50 by 4. So on further solving, it comes out to be 62.5 degree Celsius. So option 4 is the correct answer. Let's move to question number 25. In question number 25, in a LR circuit, the AC source has voltage 220 volt and potential difference across the resistor is 176 volt. The power factor of the circuit is. So we know that the power factor cos phi is given by R by Z. Since the current is same in R and L, so this can also be written as potential difference across resistor divided by V net. So this is equal to 176 divided by 220. So if I solve this, it comes out to be 0.8. So option 2 is the correct answer. Let's move to question number 26.